Yesterday we looked at the double angles. T results you can kind of think of as half angle results. T represents the tan of theta on 2. And so let's start with our tan 2 theta result. So we get 2 tan theta on 1 minus tan squared theta, but if I have theta instead of 2 theta, double angle, then half of theta is theta on 2, and we get 2 tan theta on 2 on 1 minus tan squared theta on 2. But now that I've defined t to be tan theta on 2, I can turn it into 2t on 1 minus t squared. What this has the advantage of, I suppose, is it turns trig into a polynomial. And that can help with certain manipulations and things like that. Alright, well let's draw up a triangle. If tan is 2t on 1 minus t squared, we'll make the opposite 2t, the adjacent 1 minus t squared. Bit of Pythagoras, we want to work out that hypotenuse. And h turns out to be, there we go. So t squared plus 1 squared, hypotenuse is t squared plus 1 or 1 plus t squared, however you prefer to write that. We can now read off our triangle and get the t results for any of the other ratios. So if t is tan theta on 2, we know tan theta 2t on 1 minus t squared, sine theta 2t on 1 plus t squared, and cos theta 1 minus t squared on 1 plus t squared. Now note, again, just like double angles, don't think of it as 2 theta. You don't think of this as theta on 2, think of it as half angles. So that way, if you want to make t equal tan theta, then tan 2 theta would be 2t on 1 minus t squared. If t was tan 2 theta, then tan 4 theta would be 2t on 1 minus t squared. Well, there's no reason why you have to make t be tan theta on 2. You just halve the angle that you're dealing with. That's what you make it. So let's prove this little identity. 1 minus cos x on sin x could simply be t if we're using our t results. So it's important we define what t is. Otherwise that would be a pretty tricky question to do if we didn't know what t was. So 1 minus cos x on sin x. So in our t results, so x is double x on 2. So we can use our t results. 1 minus t squared on 1 plus t squared, 2t on 1 plus t squared for the sin x. The nice thing about fractions when you're using t results, if it just involves sine on cos, they of course have the same denominator. So the cancelling is quite easy. You just multiply everything by the denominator. And I have 1 plus t squared minus 1 minus t squared, which tidies up to be, what do we got there? 1 minus 1 goes away. Minus minus becomes a plus. We have 2t squared on 2t, and sure enough, that simplifies down to be t, which is what we were looking for. It gave us a bit of a hint here. Use t equals tan theta on 2 to simplify that. So we've got 2 tan 75 on 1 plus tan squared. Well, if I let t equal tan 75, when they've given me the hint, use the t results. So let's t be tan 75. In other words, we're saying that half of the angle is 75. So the angle we're talking about is 150. So 2 tan 75 on 1 plus tan squared 75, which is 2t on 1 plus t squared, if I like. Well, that's sine theta. But remember, theta will be double the angle. So 150. Sine of 150, second quadrant. Sine's positive. The acute angle would be 30. Sine 30, half. 1 plus sine theta minus cos theta on 1 plus sine theta plus cos theta. Okay, so we'll use our t results to make this a little bit easier. Again, the advantage of using t results is we get this trig and turn it into an algebraic fraction. And again, it only involves sine and coses, so the denominator's the same in everything. So multiply through by 1 plus t squared. And now a bit of tidying. So on the top, what we got? 1 plus t squared plus 2t minus 1, so the 1's go. So I'm going to have 2t squared plus 2t on top. What happens on the bottom? The t squareds cancel in this case. So 2t squared plus 2t on 2 plus 2t, factorise, and then we can do some cancelling, and we just have t. Now, the temptation is to stop there, but remember, that's not what the question asks. We have introduced t into this question. They've actually asked us to prove it's tan theta on 2. Well, we define t to be tan theta on 2. So there's just one little step left and say, well, that is indeed equal to tan theta on 2. an HSC question. So again, they've given us the hint to use the T results for this. We're going to show cosec plus cot is cot theta on 2. Okay, T results. Well, cosec's the reciprocal of sine, cot's the reciprocal of tan, so we'll turn those T results upside down. Nicely, the denominators are the same, so those fractions will add together quite nicely, just to get 2 on 2t, which is 1 on t, which is the reciprocal of t, and t was tan theta on 2, so we've got cot theta on 2. So 17F, we'll play with our T results.